Good morning to everyone. Nagarjuna from Suryahana Academy. So we're going to start today's session. So in the yesterday's session, we were looking at what is delta merge, different types of delta merge, and difference between a row table and a column table, and when to use what table. So in today's session, I'm going to complete the pending topic that I was supposed to take on Friday. But Friday there was a class off. So I'll continue the class that I was supposed to take on Friday. I'll continue that class today. So on the Friday, the topic was calculation views of type cubes. So in here, I'll right click on the calculation view, click new. So create an information view of type calculation view. So calculation views basically have, we discussed in the past, dimension, cube, and cube with star join. So today we are going to create calculation views of type cubes. So I'll give the name as CV underscore actual underscore plan underscore copa underscore data underscore cube. So data category is a cube. If you set the data category as a cube, the default node is aggregation. I'll click finish. I'll click finish. So once we click finish, so what is the default node? Default node is an aggregation. So what I can do with cubes? With cubes, we can use data sources like attribute views, analytic, calculation, and tables. So I'll click on the projection, I'll right click on the projection 1, click rename. I'll give in here actual. I'll click OK. Select the analytic view actual, drag and drop into the actual projection. Click on the projection again. Right click on the projection 1, click rename, plan, and click OK. Select an underscore copa underscore plan underscore data and drag and drop this analytic view in plan projection. So what columns I require from actual projection? So I'll select the required columns over here. So for example, I require oops. I think these analytic views are partially built or they have been modified. You see here only we have a time attribute view. So these are only partially built. So I'll just drag and drop the other attributes. For some reason these are not. So I'll just first complete this activity and then I'll go to the calculation views of type cube. Because these analytic views are partially built, I'll just complete to build quickly and then we can quickly go to the calculation views of type cubes. So I'll select customer product Bucharest it seems one of our participants is already created. So let us use them. So it's already there it seems. Let us check. ECC underscore PG. So for example, if you have these data models in other package, what we can do is we can either copy or we can refactor. Refactor means when you right click on this view, you can move this object from this package to a different package. This is known as refactor. So from this package, I can refactor move. I can move to my package. Means this is like cut and paste. But I can also copy. So I'll right click, copy, right click and copy. and then I can paste. Right click on the Anly view, click paste. Click OK. So object is copied. So once it is copied, it is inactive. So right click and then click activate. Either you can activate like this if you want to activate group of objects. So I'll also copy the other analytic view and I'll activate group of objects. So I'll copy again the plan analytic view. Right click and paste it over here. I'll click OK. So now I have both actual as well as plan analytic views. So now I'll right click and click activate. So once I click activate, I can activate group of objects. So it will show all the available objects, and here I can see the selected ones. So I can basically go to the package which is ECC March 730. I can activate group of objects together. So ECC March 730. So these are the two views that are inactive. So I can add. Now I added both of these views, and then you can click. Already the validation is completed because we are already copying from an existing view. So I'll click activate. Once I activate both these views, activation completed successfully. So refactor is to move, copy, copy and paste. That is cut and paste. So now we have both these analytic views. So I'll again double click on the calculation view of type cube. I'll remove these analytic views. I'll remove this and I'll replace them with the new ones. So I'll select AN COPA actual data into the actual projection and AN COPA plan data into the plan projection. And then here we're going to click on union, click union on the work area, link actual projection to union and plan projection to union. So here you see no columns are added to the output. Means we haven't added any columns to the output. I'll click on this. I'll select required columns. I'll select KUNNR, name1, land1, landx, regio, bjdi, and buKRS. All the attributes from customer and company code and sales organization. And measures VV010 and VV070. So these are the columns I'm selecting from actual, and I'm now selecting from plan. I select measures. Now finally, both these views, the sources are available here in the union. Now we are in the union node. Both actual and plan columns are available. I'll select column from actual, right click, add to target. And then I'll select plan. And here we will auto map by name. So here we have 4 measures. So in this case, I'm not going to take indicator. So we remember the other day we created an indicator. An indicator is basically used to identify what rows are coming from what projection. So I'm not going to create an indicator. I've directly added columns to the target. So we have actual gross revenue and plan gross revenue. So based on this output, I'll link union to aggregation. I'll click on aggregation. At the aggregation, I'll take all the required columns, all the attributes, all these are attributes, and these are measures. So right click, add as an aggregated column. So you can just select all of them at once. Shift and select, right click, add as a aggregated columns. So once we add, these 4 columns are available as aggregated column. Now I can right click on the calculated columns, click new calculated column. I can create a calculated column for variance. I'm creating a calculated column for variance. Decimal. Length is 15, scale is 3. Column type is a measure. So in here we have elements. In elements, I'll select columns. So here you have measures. So VV010 minus VV01001 minus VV010 provides me variance, the difference between plan minus actual. So once you have given the measure, I'll click OK. I'll click OK. So in here you see now I have the difference between actual versus plan. I don't require these columns now. I don't require these columns. So I'll select each of this column. So here you have hide as false. I'll make it true because I don't want to display these columns in the output. So I'll select these columns and hide as true. And I only want to display the output of this column, which is VV01001 minus VV010, which is the variance of actual and plan. The semantics, so we have done a calculation. I'll click on the semantics. The hidden ones is not highlighted, so they are basically not highlighted. I'll validate and click save and activate. So what am I trying to show here is we have done similar to calculation view of type cube. But the only thing that we have done here is instead of calculation views of type dimensions and taking base tables, creating calculation views of type cube with star join. Inside an analytic view, when I right click and open the analytic view, and when I open any of these attribute views, already we created calculation views of type dimensions in the form of attribute views. I'll click back, and these attribute views are already part of the analytic view, which created a column view of type analytic view, which created a column. Please see here, when I open data preview, already a column view, and I click raw data, click on show log, double click on generated SQL, already a column view of type analytic view is generated. Now I'm taking this analytic view as a data source. So In this analytic view, we already have attribute views as a part of it. Please see this group by K1 and R, all these are the part of the analytic views. I'll click close and close. So yesterday we were discussing about the views and execution of these views on different engines. So when discussing, we were trying to highlight few points. One point was when an attribute view individually when it executes on a join engine. When you use an attribute view inside an analytic view as a dimension to an analytic view, these attribute views when used inside an analytic view, attribute views now execute on OLAP engine when they're the part of the analytic view. When attribute views have calculated columns, attribute views execute on CE engine. So let us see this example. Now we know when individually executed JE, when attribute views used inside an analytic view executes on OLAP. When an attribute view has a calculated column, for example, excuse me, when I go back and here I've created calculation view of type cube. This is the one I created, calculation view of type cube. And here you have an analytic view. I'll open this analytic view. I'll open AT customer. And here at the data foundation, here we see calculated columns. So basically I'm trying to explain two topics over here. The first topic is what is the purpose of creating calculation view of type cube? You can take analytic views as data sources. What is the purpose of cube? We can use different operators like join, union, projection, aggregation, rank, and we can use all these operators on these data sources like analytic views. In an analytic view, attribute view is a dimension. Attribute views, when individually executed on a join engine. But when this attribute view is a part of the analytic view, now this is the analytic view, it creates a start join. It executes on OLAP engine. But when an attribute view has a calculated column, I'll right click on a calculated column, new calculated column. I'm creating a calculated attribute. It's not a measure. I can create calculated attributes inside an attribute view. So basically, I'll take a simple example. So name 1 and name 2. So there are two names, name 1 and name 2. I would like to concatenate both these names. Let's say I give it as full name. Varchar, length is say 60. Expand columns. So name 1 plus name 2. Click OK. Now we have full name, which is the formula is name 1 plus name 2. So now we have this calculated column. So when you have a calculated column called full name, which is name 1 and name 2, now when you have this calculated column inside an attribute view, this directly goes and executes. Now because this is used, this analytic view is used inside this attribute view is used inside an analytic view. Usually, where does analytic views execute? On OLAP engine. But when an analytic view is using an attribute view, and if this attribute view consists a calculated column, then this executes on CE engine. Indirectly, an analytic view is executed on CE because of this calculated column. It skips the OLAP. It executes on CE. So let us see this. So I'll go back. Excuse me. I'll go back here and then I'll copy. I'll right click on this analytic view. I'll click copy column view name. I can directly go here and copy column view name. I'll go to catalog. I'll expand the catalog. I'll go to the schema underscore sys underscore bi. I'll expand the schema. On the column views, I'll right click on the column view, click filters, copy paste the column view. I'll delete the schema, click whole word and click OK. Expand this. Oops, okay, I'm not able to see. Filters again. Sorry, I should be seeing in sys BIC, not BI. Sys BIC. I should be seeing in sys BIC. I'll click whole word and click OK. So here we see this orange color is the analytic view. If I double click, if I click on create statement, I click on create statement. So the column view is the analytic view here. So this is the analytic view. So do we have here, do we see full name? In these columns, we don't see full name. So I'll go back to this attribute view called AT customer because I haven't activated yet. This view I did not activate yet. I'll validate and save and activate. Now once I save and activate, this attribute view is used in this analytic view. Now I'll right click on the column view. Now this analytic view, when I right click on the column views and refresh, when I refresh TC, the orange color changed to a small calculator. This is a calculation view. Now why did it change is because of the only one reason is there is a calculated column, calculated attribute inside an attribute view. So when I double click on this calculation view, we see here the full name, the 17th column, full name. And when I click on create statement, you see it created a calculation scenario. So it created a calculation scenario. So now when I go back again, so when you have a calculated attribute inside an attribute view, if this attribute view is inside an analytic view, and analytic views execute on the CE engine. They create a column view. They create a column view of type calculation view, and they execute on a CE. They execute on CE engine. JE, OLAP, CE. So one last time again, attribute views individually executed on JE. Attribute views when used inside an analytic view executes on OLAP. Attribute views when they have a calculated column, and these attribute views used in an analytic view execute on calculation engine. Now, I've used an analytic view as a data source. I use an analytic view as a data source for calculation views of type cube. The cube the default node is an aggregation. For analytic views, the default node is an aggregation. For attribute views, the default node is a projection. For calculation views of type star join, the default node is star join. Star join executes on SQL engine. Cube executes on CE. OLAP executes on analytic views execute OLAP. Attribute execute on JE. Analytic views are the data sources for calculation views of type cube. Please see here. Excuse me. Analytic views are the data sources for calculation views of type cube. So if I go back to the HANA Studio, I'll close the catalog. I'll open this calculation view. Double click on the calculation view. So please see, what is this? Cube. So can a cube have analytic views as data sources? Yes. Okay. Now when you have an analytic view as a data source inside a calculation views of type cube, which engine does it execute? So here, a union is an operator that is executing inside a calculation engine. Aggregation is an operator that executes inside a calculation engine. So when I right click on the calculation view, copy column view name, I'll go to the catalog, expand the catalog, go to the schema, right click on the column views, right click and click filters, copy paste the name, click OK. So here you have, these are all the dimensions. When I double click on this, now this is the output of the calculation view of type cube. Create statement. So this is the statement that is generated by system. This is the SQL script that is created by system. So now when I have analytic views as a data source to calculation views of type cube, first they execute on OLAP. After processing is done inside the OLAP, the results are transferred to CE for the rest of the operations like union. So when these operators are involved, it executes CE underscore union. CE is nothing but calculation engine. CE underscore aggregation. So these are the functions, C function, C aggregation, C union that are available inside the calculation view. So simply to say, whenever we use an analytic view as a data source to a calculation view, first it executes an OLAP. After processing here, the results are transferred to calculation engine. So both these engines are involved when executing of the calculation view of type cube. And the last one is star join itself. Now we discussed about star join. Star join by default executes on CE, but then you can execute on SQL engine. For a star join, it doesn't allow attribute views or analytic views as a data source. So we have to use a special calculation view which is known as calculation views of type dimensions. So a calculation view of type dimension, a calculation views of type dimension are used as providing master data to the calculation views of type start join. So both of them execute on SQL engine. So what's the advantage is it executes faster. How fast when you compare with C engine? 50 times faster it executes when you compare with C engine. So the next topic, so once we complete this topic, then next we'll move on to the data provisioning topic. We'll see other complex modeling. I'll discuss about currency conversions, unit of measure conversions, transporting of objects. Once we complete the data provisioning topics. So now I'm going to start with a topic called BODS, Business Objects and Data Services. So before that, if you have any questions on this, before I start a new topic, any questions, we can go ahead. I'll also discuss about scripting as a separate topic. We'll discuss SQL script. First we'll discuss SQL and then we will discuss SQL script. So here, when we're importing data from BW, can we directly use cubes which are available in BW? Yes, we can use it. So when you import a cube from BW, it converts to an analytic view. You can also convert to a calculation view. There are choices on how we can import. Either you can import as an analytic view, you can import as a calculation view. First, I'll just give a brief introduction. Okay, then. So I'll just give a brief introduction about BODS. So BODS, Business Objects and Data Services. This is an ETL tool. It's a ETL, extract, transform, and load. You extract data, we transform, and then finally we load data. Now there are two important components in BODS. There are two important components. One is known as job server. The second one is known as repository. One is a job server, and second one is a repository. Now BODS is an ETL, extract, transform, and load. So we extract data from heterogeneous source systems. Either you can get data from ECC, you can extract data from non-SAP systems. You can extract data from ECC, ECC connected to BODS, non-SAP connects to BODS, and then finally you can get data to HANA in this case. But also not only to HANA but also to different databases. So BODS is an ETL tool, extract, transform, and load, business objects, data services. ETL, extract from heterogeneous sources. You can transform. You can apply business rules. After you massage data over here, according to the business requirement, finally I can send to HANA. Now, there are two important components we discuss, job server and repository. Now, what is the use of both these components? For example, we have a table on ECC. Let's say the table name is KNA1, which is a customer master table. Now we know this table has container as well as content. Container is nothing but the metadata. Metadata is nothing but data about data. Data about data is nothing but what is the data type and length of each column. So metadata is nothing but, for example, KUNNR is a column. What is the data type? Varchar. What is the length? 20. This is nothing but the metadata. Technical properties of a column, metadata, or the container that holds the content. So metadata, if I want to take this table called KNA1, there are two different things over here. One is the container itself is the metadata, and the second one is having the content inside this container. Now this is known as data. I'll just give a very simple example. Now let's say we have overhead tank and there is an underground tank. Now what is my requirement here is I want to transfer water from the underground tank to the overhead tank. Now let's say this is HANA. Overhead tank is HANA and the underground tank is ECC. Now if I want to connect both of them, first I need to have a pipeline. I need to connect through a pipe. So first what I'm going to create a connection. So using a pipe, I'm going to create a connection. Once I connect both source and target, then if the table is available on the ECC, I can transfer via this pipe to HANA. So this pipe is known as BODS. So BODS never hold data. It only facilitates to transfer data from source to target. And then if you want, you can purify water in between. Nothing but cleansing of data. You can massage data. You can cleanse data according to the target requirement. Now, I have source, I have target, I have pipe. Now, if I want to transfer water from source to target or table data from source to target, I require a motor. Without a motor, I cannot initiate the water transfer from source to target. So this motor is nothing but job server. BODS is a pipe or a middleware, and the repository contains metadata. So simply to say, you have source, you have target, you need to first create a connection. Without a connection, we cannot transfer. So first step is to create a connection. Once the connection is established, then we have to switch on the motor, which is nothing but the job server. So job server initiates the data transfer between source and target. And the repository holds the metadata, nothing but information about the container. Now tell me, without a container, I cannot hold content. Nothing but the skeleton of a table. So if I want to take this table called KNA1 to HANA, first I require the container. So this container is nothing but the metadata. Metadata I'm going to store in the repository. So what is repository? Repository is a collection of metadata, or it's a collection of container information. So when I have the container information here, which are nothing but the table's structure or the columns inside the table, I only have the structure. So based on the structure available in the repository, I'm going to copy this structure to HANA. I'll copy this. I'll take an image. How I see myself in a mirror. I see myself in a mirror. So basically, it mirrors this table. We take an image of this table in the repository. It takes an image, a copy. It takes an image of this table. Taking an image of this table is known as a template table. Template. Template means you're taking a template of a document, means you're copying. You're taking a template of this table and creating this template in Target. But from where HANA is getting this template? From repository. From where repository is getting this table? From ECC. ECC and BODS are connected. ECC and BODS are connected. Connected through RFC, remote function call. Now this is the interface or the protocol where ECC and BODS communicate to each other. So this table I'm going to import to repository. Repository is a collection of metadata. A container, this container first I'm going to create in HANA. Once the container we have, then using the job server, once I switch on the motor, which is nothing but the job server, it initiates the data transfer. The content which is available in the table is now transferred via job server to HANA. So BODS has two important components. One is the repository and the job server. Repository is a collection of metadata. Job server which initiates the data transfer. The connection which is a pipe like BODS. To establish a connection between source and target, I'm creating a tunnel. So from this tunnel I can transfer data from source to target. This tunneling of source and target, this tunnel is known as data store. So what is a data store? A data store is nothing but connection. So you establish a connection. Once the connection is established, the next thing is import the container information to repository. Based on the container information, I'm going to create a container in HANA. Initiate the job, goes to source, fetch data, and transfer to HANA. An initiation of these jobs is done through a regular interval of time. So every time I trigger an alarm saying that, okay, daily at 8 a.m., trigger an alarm. This alarm triggers the job server. This job server will initiate the data transfer. So every day at 8 a.m., transfer the entire contents of the customer information on the source to HANA. So I can do job schedule. I can schedule a job. So once I schedule a job, the data gets transferred on regular intervals of time. I can configure in such a way I can schedule these jobs in a regular interval of time. So that's why ETL, extract, we extract not only from SAP, also from non-SAP, transform. You can transform data according to the business requirement. You have different kinds of transformations like merge, case, data cleanse, and finally load to the associated target system. BODS, business objects, data services. In business objects, there are primarily two roles. One is the admin activity. The admin activity, nothing but we have to basically configure all these things together. This is done by BODS admin. On the other hand, we have, as a part of HANA application team, you are working on the ETL flows. Working on the ETL. We create ETL. How we can transfer data from different source systems to target systems. I create an ETL flow. This creating of ETL flows is my responsibility. But for little senior positions, we also have to involve in the admin activities. So we'll see from the admin point of view how we can configure all of these things, and then I will show you from the application point of view how we can perform these activities. So that we will see in tomorrow's session. Just to conclude, BODS has two important components: job server to transfer data, nothing but the content, repository collection of container information, nothing but the metadata. A connection between source and target is known as a data store. A data store is a connection. So tomorrow we'll see relation between all these three things and how we can configure these three things in the system. Thank you for attending today's session. If you have any questions until here, please type in your questions. I'll read the questions and answer your questions. Thank you. So here we have a question. I thought Smart Data Access is used for data transfer from non-SAP to HANA, and BODS is ECC to HANA. Am I right? So BODS has a flexibility to transfer data from heterogeneous systems to target. What Smart Data Access cannot do and what BODS can do. Smart Data Access cannot transform data, and BODS can transform data. So we can apply business rules in BODS, but in Smart Data Access we cannot apply business rules. So that is the difference. In repository we have content. In HANA, do we need to create the content, or it can be imported from repository? There are actually two ways that you can do with the content. Oh, sorry, you're talking about the content. So in repository we have content. No, we don't have content, we have the container information. So repository has the container information, does not have content. Content is transferred via the job server. The job server is the part of BODS. So BODS will never hold content. It never holds the content, but it only initiates the transfer of content from source to target. So tomorrow we're going to start the first class on data services. Please go through the book HA350. HA350 is the book for data provisioning, and you have a topic called BODS, Business Objects Data Services. Thank you everyone to attend today's session, and we will see you tomorrow, same time. Thank you.